More than 370,000 built over 80 years. No machine tool in history has reached that number, and no single design has worked its way so deeply into the daily life of machining, from U.S. Navy aircraft carriers to suburban home garages. Even more astonishing than the number is the lifespan. Many of those machines are still cutting metal today, nearly a century after the first one left the factory. That machine was the Bridgeport Series I, the knee mill that defined the North American machine shop. Its influence became so large that the proper name turned into the generic name for an entire class of machines. Walk into almost any shop, point at a vertical mill, and ask the machinist beside it what it is. The answer will almost always be the same. That's a Bridgeport. They may say it even if the raised letters cast into the machine say something entirely different, the same way people call every tissue a Kleenex without ever looking at the box. An achievement of that scale, you might assume, must have begun inside the research department of some industrial giant, with a deep bench of engineers and a bottomless development budget. But the truth is almost the opposite. The story of Bridgeport began with a complete commercial failure, a product that never truly made it to market. By the end of this video, you will understand why a design born in 1938 has never needed a fundamental redesign in nearly 90 years, and why the company that created it could go bankrupt. The factory could be torn down, and yet the machine itself could not be killed. Before we begin exploring this legendary machine, don't forget to like the video and subscribe so you don't miss the next journey into the machines and the people who built the industrial world. Every story like this begins with the people behind the machine. Gothenburg, Sweden, April 15, 1897. Rudolf Fredrik Banau was born into a country watching a vast wave of working-class migration leave for the far side of the Atlantic. At the age of 13, he crossed to Massachusetts with his family, joining a Scandinavian immigrant community searching for work in the factories of America's Northeast. Banau trained as a pattern maker, the craft of carving precise wooden patterns used to form sand molds for metal casting. At the time, it was among the most demanding trades in mechanical manufacturing. Every gear, every housing, every machine body began as a wooden form before it became iron or steel. A pattern maker had to understand geometry, materials, and the way metal shrinks as it cools inside a mold. In other words, he had to understand the entire chain of production, not merely one step within it. That foundation would later shape the way Banau saw a machine, not as a collection of parts, but as a single whole that had to be right from its first physical form. In 1927, at the age of 30, he bought the Bridgeport Pattern and Model Works at 143 Cannon Street in Bridgeport, Connecticut, using his savings and a $3,000 loan from his mother. The second man in the story came from Surahammar, a small town in central Sweden whose entire existence had been tied to iron-making since the 17th century. Magnus Wallström grew up in a place where iron was the only industry that truly mattered. He worked in the machine shop of the local steelworks and developed tool-making skills from a young age. In 1923, he immigrated to the United States, first landing in Chicago, where the Swedish immigrant network eventually connected him with Banau. By 1929, Wallström had moved east, and the two men became partners. To understand why this partnership mattered, we have to look at the American machine tool market in the late 1920s. Milling machines of the period were overwhelmingly horizontal machines, massive cast iron structures, specialized and purpose-built for large factories and high production. If a small shop wanted its own dedicated vertical milling machine, The price could be around $7,000, roughly the value of several houses at the time. Yet the shops that needed versatility the most were the job shops, small businesses taking on everything from repair work to prototypes to one-off manufacturing. They also had the least money to spend. The machine tool industry saw the big factories. Thousands of small shops across America were almost invisible to the companies building the machines. That narrow gap in the market could not be filled by a machine tool giant, because the giant could not feel it. It could only be filled by people living inside that gap. Banno and Wallstrom did not study the needs of small shops through market reports or surveys. They were a small shop. They knew what it felt like to turn down a job because the right equipment was missing. They knew the pain of watching an expensive machine sit idle because it could do only one thing. The legendary machine that was about to be born came from the daily frustrations of two immigrant craftsmen who understood their customers down to the bone, because their customers were people like themselves. But the road to the milling machine began with a wrong turn. When the Great Depression struck and industrial orders dried up, Banno and Wallstrom decided to bet on a consumer product, an electric hedge trimmer. If it had succeeded, this story might have ended there. Their reasoning was not foolish. If factories had stopped buying equipment, perhaps homeowners might still spend a little money on their gardens. The two men spent more than a year developing the product. The result was nothing. The hedge trimmer never became a commercial success, and more than a year of effort and scarce resources from a small shop in the middle of the Depression had nearly vanished. But fate has its own way of knocking. While the two men were still wrestling with hedge-trimming blades, the Atlas Tool Company of Bridgeport came to them with a very different order, a high-speed, 1/4 horsepower milling head that could be mounted onto existing horizontal milling machines to perform vertical milling operations. For a shop desperate for work, there was no reason to refuse. In 1932, they delivered the first milling attachment, and unlike the hedge trimmer, it sold. The success of that milling head created a feedback loop, and the two Swedish craftsmen were perceptive enough to listen. By 1936, they had upgraded the product to a half-horsepower version with a quill, a sliding sleeve that allowed the spindle to move straight down into the workpiece like a drill press. It made drilling and end milling feel natural within a single setup. Machinists loved it. Orders flowed steadily back to Cannon Street, but along with the praise came a complaint, repeated so often that it could no longer be ignored. Your milling head is excellent, but the old horizontal machines we have to mount it on are not. Customers were buying a strong heart and being forced to transplant it into worn-out bodies. Banno heard that complaint enough times to realize it was not grumbling, it was a design brief. Around 1936, while on a sales trip, he pulled out the only thing at hand, a paper bag, and sketched the solution on it. The drawing on that bag was no longer an improved accessory. It was a complete machine, with a column and base designed from scratch for one purpose, to carry the milling head they had refined through 4 years of real customer feedback. The machine would be lighter than almost anything else on the market, more versatile than specialized machines, and most importantly, priced for the class of customers the industry had forgotten, small shops that had never dared dream of a $7,000 vertical mill. That backward sequence of invention is the key to understanding the entire Bridgeport design philosophy. Most machine tools are designed from the top down. The overall machine is imagined first, then divided into assemblies and components. Bridgeport came from the bottom up. A market-proven attachment went looking for a proper body. The head came first, the machine came later, and that is why the head was naturally removable, not because of some forced design decision. That modular nature, born from the product's own history, would follow the machine throughout its life, allowing users to swap heads, upgrade components, and repair individual assemblies across decades. On August 8, 1938, the first machine left the shop, carrying serial number 1. It was sent to Precision Castings Corporation in Syracuse, New York, and sold for $995, less than 1/7 the price of a dedicated vertical mill of the period. The sketch on the paper bag had become iron and steel, and neither of the two Swedish craftsmen that day could have imagined that the 2,000-pound mass of cast iron being loaded for delivery would become one of the most successful machine tools in human history. To understand why the design won, the best method is to dissect it from the bottom up, following the path of cutting forces through the machine. At the foundation stood a heavy cast iron base and column, providing the rigidity needed to absorb vibration as the cutter entered the metal. Sliding vertically along the column was the knee, raised and lowered by an Acme screw, giving the machinist control over the vertical axis through a hand wheel. On top of the knee sat the saddle, moving front to back. On top of the saddle sat the table, moving left to right. 3 axes of motion, all controlled by hand wheels, all accurate enough for toolroom work. Up to this point, the machine was a well-made knee mill, but not yet something that would force an industry to rewrite its assumptions. The genius was at the top of the column. There, Banno placed a turret capable of rotating a full 360 degrees around the column axis. Passing through that turret was the ram, a sliding arm that allowed the entire cutting head to reach forward, pull back, or move to almost any position around the table as the turret rotated. At the end of the ram was the milling head itself, refined through 4 years of market feedback, now able to tilt in 2 independent planes. Add the quill, which allowed the spindle to feed straight down like a drill press, and the machinist had a machine that could cut compound angles without removing the workpiece from the vise even once. The essential point is that no single feature created the revolution. Rotating turrets had existed. Tilting heads had existed. Quills were common on drill presses. What had not existed was the combination of all of them in one machine that was light enough, affordable enough, and rigid enough. That combination reversed the traditional logic of machining. Instead of bringing the workpiece to the cutter, the machinist could bring the cutter to the workpiece. For large, heavy, or awkwardly fixtured parts, that reversal was not a convenience. It was the difference between possible and impossible. Every time a workpiece is removed and set up again, error accumulates. A machine that reduces setups is a machine that preserves tolerance. Banno filed for a patent in April 1939, and on March 3, 1942, patent US 2275291A was granted under a title that described the design philosophy precisely: machine tool operating at universal angles in overall locations. Bridgeport Machines Incorporated was officially formed in 1939, completing the transformation from a pattern and model shop into a machine tool manufacturer. The question the machine tool industry had not bothered to answer was simple: how can a small shop machine like a large one? The answer now sat on a 2,000-pound casting. All that was missing was a world event large enough to make everyone recognize it. That event arrived at the end of 1941. In December 1941, the United States entered the war, and the nation's industrial machine pivoted toward military production almost overnight. The War Production Board faced a brutal problem. Factories needed machine tools that were versatile, quick to set up, and simple enough for newly trained workers to operate, because many experienced machinists were being pulled into uniform. Measured against those requirements, the machine created by Banno and Wallstrom matched every one. It was compact enough to fit inside the repair compartment of a submarine and accurate enough to machine aircraft components. The machine born for the small shop turned out to be exactly the machine demanded by the largest industrial war in history. Orders poured into Cannon Street faster than the company could possibly fill them. The factory ran day and night, 7 days a week, and still could not keep up. In 1941, the company added 2,400 square feet. In 1944, it added another 4,200 square feet. It still was not enough. Production milestones arrived in a rush that the two founders could hardly have imagined when Banno sketched the design on a paper bag. Machine number 5,000 left the factory in January 1945, and machine number 10,000 followed in 1948. Somewhere within those numbers, the company quietly abandoned the craft that had created it. Pattern making was discontinued, and the entire shop floor was devoted to milling machines. Bridgeport Pattern and Model Works had become Bridgeport machines in the fullest possible sense. One detail says more than any statistic. On the submarine USS Pampanito, which completed 6 Pacific War patrols and is now a museum ship at Fisherman's Wharf in San Francisco, an old Bridgeport remains bolted to the engine room deck. In recent years, it has even been fitted with a digital readout to help machine parts for restoration work. 8 decades after it left the factory, inside a floating museum artifact, that machine is still making chips. During the war, the meaning of such machines was direct and vital. A damaged submarine in the middle of the ocean could not wait for parts to be shipped from shore. A milling machine bolted to a steel deck could be the line between self-repair and helplessness. What separated Bridgeport from many wartime products was what happened after the shooting stopped. Industrial history is filled with companies that expanded on military contracts and then collapsed in peacetime. But demand for this knee mill did not contract. It simply changed destinations. Millions of demobilized servicemen returned home with mechanical skills learned in the military. Machine shops appeared across America to serve the booming consumer economy. And the first machine that many new shops bought was a Bridgeport. In December 1951, the company moved into its large new factory at 500 Lindley Street. Machine number 20,000 left the line in 1954. Machine number 100,000 followed in 1967. From a sketch on a paper bag to 6-figure production in less than 30 years. Hundreds of thousands of machines were not produced by endlessly repeating a frozen design. They came from evolving in the right places, and because modularity had been built into the product from the days when it was still an attachment, Bridgeport's evolution took place mostly where change was easiest, in the head. The original M head gradually gave way to the J head, with a step pulley design and a 1-horsepower motor. More important than the added power was the tool-holding system Bridgeport designed from scratch, the R8 collet. The R8 is a tapered collet system that allows the machinist to change tools quickly, securely, and concentrically. Viewed alone, it is a modest technical detail, but the fate of the R8 is one of the clearest proofs of the company's design intelligence. It was accepted so widely by the market that it escaped the boundary of a proprietary part and became an open standard across the industry. Thousands of milling machines from dozens of manufacturers still use the R8 taper today. In the late 1960s, the 2J head appeared with a variable speed drive, allowing the machinist to adjust spindle speed with a dial while the machine was running, rather than stopping to move belts. Every step in Bridgeport's evolution carried the same signature, not theatrical, not disruptive, but quietly reducing the distance between the machinist's intention and the machine's response. The strength of the Series I was not that it was untouchable. It was that it was so right that every attempt to do it differently only made the original look more correct. Ironically, that same quality, an open, simple, elegant design that was relatively easy to manufacture, would soon become the company's Achilles heel once the patents began to expire. In 1968, Textron acquired Bridgeport Machines for about $11 million, a deal Forbes would later describe as one of the early casualties of the conglomerate wave sweeping through American industry. In 1986, Textron needed money to acquire the defense conglomerate Avco and decided to sell its machine tool division. Bridgeport returned to the hands of its own management through a $77 million management buyout. Independence came back, but it came with turbulence. Workers unionized within days of the deal, and a year later, 220 employees went on strike. While the company was still dealing with internal disruption, a far larger threat was forming quietly across the Pacific, and it began with a legal event that seemed harmless enough. Bridgeport's core patents had been expiring through the 1960s and 1970s. This was the fatal blow, and its mechanism was deeply ironic. The Bridgeport design was open, elegant, and relatively easy to cast. The very qualities that had helped it conquer the market now became a free instruction manual for anyone with a foundry. An army of clones rose from Taiwan. Jet, Sharp, Acer, Kent, Grizzly, and dozens of others produced knee mills that looked almost identical, used the same R8 taper that Bridgeport had turned into an industry standard, and often accepted parts interchangeable with the original machines. A clone might cost around $5,000, while a genuine Bridgeport cost significantly more. And the bitterest truth was that many of the clones worked perfectly well. Bridgeport could not sue because there was nothing left to sue over. It could not cut prices enough because the cost structure in Connecticut would not allow it. And it could not convince customers that the original was worth twice as much when the copy could do 9/10 of the work. The only escape was to move upward into higher-end CNC machines, and Bridgeport tried throughout the 1990s with modern vertical machining centers, but the effort failed. The knockout came in 1999 when Bridgeport merged into Goldman Industrial Group, a roll-up that gathered long-established American machine tool brands under one structure and financed the whole operation with debt. That model survived only as long as orders remained strong. When the dot-com bubble burst and manufacturing slowed, the structure collapsed. In February 2002, after 64 years of continuous operation, Bridgeport Machines filed for Chapter 11 bankruptcy. The Lindley Street factory, from which hundreds of thousands of machines had gone out into the world, closed at the end of September. But there was one truth no bankruptcy court could overrule. The market would not allow this machine to die. Just 3 months after the factory closed, in November 2002, Hardinge, the respected precision machine tool builder in Elmira, New York, signed a license agreement to continue manufacturing Bridgeport machines. In 2004, Hardinge purchased the Bridgeport brand name, drawings, and intellectual property outright for $7.4 million in cash, plus $4.1 million in inventory. The CEO of Hardinge gave the reason without ornament. No quality shop in North America was complete without a Bridgeport knee mill standing beside a Hardinge lathe. The buyer was not purchasing a production line. It was purchasing something that had become obvious within the culture of the trade, and the way Hardinge operated said much about the difference between two industrial eras. Its Elmira plant achieved 75% of the old Connecticut factory's output on only 10% of the floor space, a lean manufacturing lesson that Bridgeport itself had not learned in time during the 1990s. Ownership instability did not end there. In 2023, the brand passed to Encompass, part of TJM Capital. In 2024, Hardinge itself filed for Chapter 11, yet the series machines continued to be produced, and that fact alone may be the strongest commentary on the design. The companies that own it may fall one after another, but demand for the machine itself has never disappeared. The obvious question is why a hand-operated machine survives in the CNC age, when automated machining centers can do almost everything faster and with repeatable precision. The answer lies in a calculation every machinist understands. Programming a CNC cycle just to drill one hole in a broken fixture can take longer than walking 3 steps to the Bridgeport and doing it by hand. For tooling, fixturing, one-off repairs, and prototypes, the manual machine remains the shortest path from problem to solution. That is why even the most advanced CNC shops in the world, despite owning machines worth hundreds of thousands of dollars, often keep at least one Bridgeport in the corner, like a pocket knife kept beside a cabinet of surgical instruments. There is another role no technology can fully replace: tactile education. Trade schools and mechanical engineering departments still teach on Bridgeports because the machine forces students to understand what is actually happening when metal cuts metal. There is no screen standing between the person and the physics. Students feel feed pressure through the hand wheel, hear chatter scream when the speed is wrong, and learn the difference between climb milling and conventional milling through the way the table is pulled under the cutter. Those lessons enter the body before they enter memory, and a machinist carries them for life, even if the rest of their career unfolds in front of a CNC control panel. More than 370,000 machines built over 80 years also created an economic consequence few could have predicted: a vast secondary market that never runs dry. Used machines constantly pass through auctions, factory liquidations, and classified listings, ending up with hobbyists, gunsmiths, classic car restorers, and engineers building prototypes in garages. Around that flow exists an entire ecosystem of replacement parts, digital readouts, power feeds, and rebuilding services, all dedicated to keeping decades-old Bridgeports turning. The machine has created a small economy sustained by its own durability. To close the story, 2 opposing images capture it best. The first is the site at 500 Lindley Street in Bridgeport, Connecticut. The great factory was demolished in 2010. Today, only a 7-acre empty lot remains, with no sign to tell passers-by that one of the most successful machine tools in history was once assembled there. The second image is spread across every continent. Wallstrom's legacy lives on the wall of the University of Bridgeport Library that bears his name, while Banno's legacy lives in 370,000 blocks of cast iron scattered through machine shops, garages, schools, submarines, and factories around the world. They are still cutting metal, still holding tolerance, still doing exactly what a Swedish immigrant sketched onto a paper bag almost 90 years ago. The Bridgeport Series I proves that the greatest machine is not necessarily the most powerful or the most precise. It is the machine an entire industry learned its craft upon, until its proper name became the name of the work itself. The company can go bankrupt, the factory can be flattened, owners can come and go, but a design that was right from the beginning does not need anyone to save it, because the market will keep it alive. Walk into almost any machine shop in North America today, point to the vertical mill in the corner, and ask the machinist what it is. You already know the answer. And now you know the full story behind it. That's a Bridgeport. If you enjoyed this video, like, subscribe to the Gear Archive, and leave a comment with your thoughts. Thanks for watching, and I'll see you in the next one.